Okay, so in this video we are going to learn Schmitt Trigger circuit. If you look this circuit carefully, that it's a positive feedback circuit because we are taking output voltage as feedback to the non-inverting terminal, so it's a positive feedback circuit. So in this video we are going to change this input voltage. We will vary this input voltage, and throughout this process we will take this reference voltage as constant. Okay, VREF, reference voltage, we will take this voltage as constant, and then we will draw a graph of output voltage versus input voltage, and we will obtain hysteresis graph at the last. So let's start. Now set EI voltage such that initially set EI voltage such that the non-inverting terminal voltage B prime, this B prime is greater than reference voltage, and if the non-inverting terminal voltage is greater than this inverting terminal voltage, we will simply get output voltage is equal to positive Vset. So actually, what is positive Vset? This is the battery's EMF. It's the battery which is used to power up the op-amp or to bias the op-amp. Okay, so the battery's EMF is Vset, and output voltage will simply equal to the positive Vset. Okay, now let's obtain a equation for this B prime. So if the current conducts in this direction, so R1, this current will go to R2, and we will now we have to write an Ohm's equation in R1. So I is equal to, you will see the voltage difference across R1 is EI minus V prime then divided by R1. Again, if you take if you use Ohm's equation, Ohm's law in across R2, you will get the voltage across R2 is B prime minus V naught then divided by R2. Okay, if you now find the equation for B prime, you will get EI R1 inverse then V naught R2 inverse, and at the denominator you will get R1 inverse plus R2 inverse. Okay, I have skipped some line, but if you pause the video and rearrange this circuit, solve this equation, you will get this formula for B prime. Okay, now what is our output voltage? It's positive Vset, right? So V prime is equal to EI R1 inverse plus, if you take the output voltage here, you will get Vset R2 inverse, then at the denominator R1 inverse plus R2 inverse. Okay, so if you look at the graph, you will see that you are now, the input voltage is, say, let's say this, and you will get the output voltage is equal to positive Vset. So you are now in this point, and what will we do now? We will now decrease EI. That means we will now go to the left side of this graph. Okay, we will now going to the left side. So what will happen? We will focus on this equation. We are now decreasing EI. That means we are decreasing EI R1 inverse, and when EI R1 inverse is equal to minus Vset R2 inverse plus V reference voltage into R1 inverse plus R2 inverse, you will see if you put this equation here, you will get V prime is equal to, if you put this thing here, you will get V prime is equal to B reference voltage. Okay, and again, if you decrease EI, this term will be less than this thing, and B prime will be less than reference voltage. And when B prime is less than reference voltage, you will see that when B prime is less than reference voltage, output voltage is negative Vset. Okay, so output voltage is equal to minus Vset. Okay, so in this graph, when EI R1 inverse is less than this thing, that means when EI is less than this, the output voltage will jumps to the negative Vset, and we will obtain a graph like this. Okay, so now if I write the equation for B prime, I will get V prime is equal to in this equation, so EI R1 inverse, you will see that output voltage is now is equal to minus Vset, right? So if I now put this in here, I will get minus Vset R2 inverse divided by R1 inverse plus R2 inverse. So what will I do now? I will now increase EI. Okay, so increasing EI means increasing EI R1 inverse. So when EI R1 inverse is equal to plus Vset R2 inverse plus V reference voltage R1 inverse plus R2 inverse. When this will occur, I will see that if you put this thing here, you will get V prime is equal to V reference voltage. Okay, and if you again increase EI, the EI R1 inverse will greater than this, and B prime will be greater than reference voltage. And if B prime is greater than reference voltage, the output voltage will be positive Vset, right? So output voltage will be positive Vset. Okay, so let's dive into the graph. So what are we doing? We are now increasing EI. That means we are going to the right hand side of this equation, and when EI is greater than this, I will get the output voltage will be positive Vset, right? So output voltage will be jumps from negative Vset to positive Vset. Okay, and then if I again decrease EI, I will get the graph like this. So it's a hysteresis graph. And my graph is not symmetrical. My graph is not symmetrical. It should be symmetrical. Okay, so it's the graph. Okay, so it's a hysteresis graph, and this point is called the upper threshold voltage BUT, and this point is called lower threshold voltage, and this point is called center voltage. And how we will get center voltage? We will get center voltage by simply averaging the lower threshold and upper threshold voltage. And what is upper threshold voltage? Let's see. The upper threshold voltage is the voltage this is the upper threshold voltage. When output voltage is equal to positive Vset, you will see the output voltage is from minus Vset to plus Vset in this point, and this point is upper threshold voltage, and in which point the output voltage goes from positive Vset to negative Vset, that is lower threshold voltage. And in this case, you will see that this voltage is called lower threshold voltage, and if you average this lower and upper threshold voltage, you will get the threshold voltage, which is this. Okay, so thank you.